Okay, that gives me a warm fuzzy. All right. So good morning. Happy Friday. This today marks 6 weeks after today, 6 weeks and one day left in the semester. And after that, you don't ever have to hear me talk about this material again. Hopefully, that's a good thing, and I mean a bad thing, and not a good thing. But where we're going with the course, we're going to have an exercise with a large municipal data set. I'm just trying to figure out some technical details concerning using cloud services because from my experience using it, you need about 16 gig to 32 gig of RAM on your laptops in order to get this thing to work practically. So I've been investigating solutions for Google Cloud. Google Cloud Services effectively allows you to bring up a Jupyter notebook, but it's hosted on Google servers. And how it works, as a student, you get $300 or something like that worth of cloud credits, which should be enough. I'm not sure how much you actually need to run your computations on their servers. The let's see, brain hiccup. What was I going to say? You can certainly run it on your own laptop, but there are those who have ultra portable um, compute devices with 8 gig of RAM that can't accommodate this data set. And so for that, we'll be using something called the Parquet format, which is a binary format versus the CSV format, which is more verbose. And we'll use that as an exercise to talk about how to pose questions. And so up to this point, the questions have been given to you, and you enterprise to answer those questions using various analytical techniques that we've talked about. But equally important in the data science process are considerations for how you pose questions and how you define certain measures that end up in your analyses. Okay, so why don't we jump right in? We are recording. So today we will talk about our last part of the Pandas API, and it's often the place where a lot of people have trouble, and that's in the merging and joining of multiple data frames. And so that's where we're going to spend our time today, where we're going to spend our time today. We're going to start with a simple concatenation, and then we're going to end up with the merge, and we'll talk about various considerations given the options associated with the merge API in Pandas. And like many things, and like I said for many other things, we can't possibly cover every single option for the API, but we'll certainly go through the mind space of how these things are implemented, because it's important to understand what happens to the underlying data structures so that if things go wrong or things go right, you'll understand or have a semblance of an understanding of why Pandas is doing in its implementation, its runtime, what it's doing. And so we certainly can't go over all the different options, but I'm enterprising to give you enough exposure for important options that you can consult the API documentation for the rest. Okay. But before we begin, excuse me, the usual administrative bits, and I'm a little bit congested this morning, not a COVID congested, but a plain vanilla winter cold congested from my daughter, which is par for the course for elementary school students. So the reading has not changed. I'll certainly update the reading on Monday's class meeting. Project 2 it has been out. It's due this Tuesday at the usual 11:59 and 59 seconds midnight. So before we continue, any questions about project number 3? No? All right. And I do advocate scrape the data once and then chop it up into epochs in time based on what you find defines those regions described or those blocks of time described in the assignment. I mean, you can certainly download the data 3 times if you choose to, but download it once. And when you do so, if you're going to chop up the CSV file into 3 parts, make sure that each part has a header line in it. Okay. All right. No questions? No? How's everybody doing on it? Okay. All right. So we're going to jump into a new topic in its entirety. And for many types of data sources, this data occurs in epochs in time. We saw that with certainly the stock data, and the municipal data we're going to examine in the future, in the near future, concerns New York City's taxi and limousine corporation, right? And so oftentimes, especially for things like municipalities, they produce regular reports because they're studying how things proceed over time on a monthly basis. It could be a weekly basis. And so often when you encounter data, for example, I have a friend who is she's the director of the Mathematical Statistics Research Department in the Bureau of Labor and Statistics. I'm trying to get her to give us a guest lecture, but she's pretty busy, Dr. Wendy Martinez. But that being the case, one of the aspects of data wrangling is going off and finding these pieces of data and then integrating them into a singular data source to which you apply the analytical techniques and visualizations and so forth. And so essentially what we're enterprising to do is to take these individual pieces of data and somehow put them together, combine them together into a singular data set. Now, certainly you've seen many of the blemishes that data sets might concern, but part of the issue with this type of operation is that there are many different choices you can make when you're building this consolidated data set. And it could be that some of these pieces of data, when you integrate them together, maybe one data set talks about housing and the other data set talks about debt. You have to put them together in some way. And it's not always so straightforward as just taking the January, appending the February, appending the March. And so the columns in these individual pieces of data might not align. Because when you're building your data set, you are building the data set to answer a question you define, but the source from which you obtain the data, they might not be producing it for your purposes. They're certainly producing it for their purposes. And so sometimes you have to build what you need by recruiting data from a lot of disparate sources, which might not always be in the form or have all of the pieces of information that you need. Okay, any questions? No? All right, so the idea of combining a data set, and we're going to go back to the basic anatomy of a data frame, and we're going to do this because we want to have an eye towards what the algorithm underneath the covers might be doing when you apply some of these data merging operations within Pandas. And so in Pandas, as we know, the star of the show, so to speak, is the data frame, and the data frame is a two-dimensional data set, and it consists underneath the covers of a dictionary of lists. And so each dictionary is a name-value pair where the name or key corresponds to the column name, and the value, a list, contains all of the records that you'd find for the data or in which the data is populated for each of the columns of this data set. We also said that a data frame has an index, and the default index here along the left-hand column is the natural number valued offset into each one of the lists in our dictionaries corresponding to a row's worth of data. And so index 0 is the 0th position in each one of the lists in our dictionaries. Index 1 is the first position, and so forth. And so the index refers to a row's worth of information, what we've been referring to as an instantiation of a vector of random variables. Any questions? Jar your memories. Okay. And so in a lot of the Pandas merging speak, they often refer to what's called the left frame and the right frame. The left frame, of course, is the data frame on the left, and the right frame, of course, is the data frame on the right. Because when they talk about the merging operations, they refer to what's going to happen with the frame on the left and the frame on the right. There are different types of merges that talk about the consideration of what you do when you're trying to put together the same or similar columns worth of information. And so it's important to understand that the mind space, the model that they have in mind, considers merging or combining two data frames at a time. Okay, any questions? No? And so in the simple case, we have the following scenario. You have two data frames, the left and the right, and these two data frames have the same columns. And if the keys or the columns are represented as dictionaries, well, we have key values which refer to the column names. And so in the easiest case, and we'll kind of make it a little bit more complex over the course of today's slide deck, in the easiest case, they have the same column names. And the idea is if they have the same column names, the intent is that each one of these columns has the same information. And so the key values then for the default behavior are used, the keys for each one of our lists are used as the basis for what parts of the left frame you put with similar parts of the right frame when you're trying to put these two data sets together. Now, this is a simple concatenation, but certainly all of the pathologies that you encounter can be varied in all sorts of ways. And so in the easy case, the two frames, left and the right frame, they have the same columns, so they line up perfectly. Line up meaning that the key names are the same. And so you can imagine the operation here would be to iterate through each one of the dictionaries in our list of dictionaries, take similar or same key names, and then extract the list associated with that name value pair, and then append the right frame's list elements for each column to the left frame's list elements of each column. And you can imagine if, heaven forbid, you were implementing this using pandas, you'd have a two-dimensional pandas array, and you do a string compare and say if the column name is the same, then you're going to slice out that column's worth of information, and then you're just going to append one to the other and insert that into a new array. Okay. Any questions about that? Does that make sense? Yeah? All right. So this is the easy case. The columns line up by their key names, and the key names are the same. And this is remembering that keys in a data frame are case sensitive, right? So if I said capital C, call one, and lowercase c in the other frame, call one, it's not the same column because the keys are different. Capitalization matters. All right. So in this case, when you do this kind of combination, the easy case, the data set gets so-called taller after combination. Now, of course, it gets taller, and there are two different options that you have in general for what to do with the index. You could, for whatever reason, choose to preserve your index. And in this case, we're presenting the default index, but like we see in financial time series, it's often the index, the default index is often overwritten with the date stamp for the trading day. And so in some cases, yes, absolutely, the resulting, and I'll use the word combine to be the result of this combination, the resulting combine gets taller, but it doesn't get wider. And it gets taller because each one of the rows worth of information for the right frame is added to that respective column worth of data for the left frame. So it grows longer. So the default index, you can keep it the same. And you might want to keep it the same for financial time series if you've replaced the default index with the date stamp. But you might want to change the index. And there are options to say, okay, Pandas, go ahead and rebuild this index. And when it rebuilds the index for the default index case, it's going to include new numbers past the index for the last one contributed by the left frame. So in that case, you'd have in the resulting combine 0, 1, 2, 3, 4, 5, and then you'd have 6 through 10. Does that make sense? But it's entirely up to you. Certainly the default behavior, which I can't remember off the top of my head, I think it's to preserve the indices. But you certainly can specify in your API call whether or not you want it to rebuild the index or keep the indices that you have in the left frame and the right frame intact. Okay. Any questions? No? No questions? Okay. All right. And so One of the questions or pathologies that can happen is what if the two frames don't have the same columns, meaning the key names are different from one another? Okay, well, there are a number of variations that you can have for that. In this example, you might have entirely different pieces of information. Maybe the left frame is um, I don't know, housing data, and maybe the right frame is financial data, open, close, and volume for some security. Now, it might be the case that because even though the key names are different, it might contain the same information. And if that's the case, you have to tell Pandas by specifying an option overriding the default behavior, even though, for example, column one has a different key from close, it's the same information. So I want you, when you do this concatenation, to treat them as if they were the same, right? But by default, if you don't override the default behavior, that's the default behavior. If you don't override it, it's going to assume that they're entirely different columns worth of information. Does that make sense? Any questions? No? All right. And so what ends up happening in the default case is that your data resulting combine gets wider, right? It doesn't get taller. And what ends up happening in the resulting data frame, you can imagine it iterates through each one of in the list of dictionaries, each one of the dictionary entries, name value pairs on the right-hand frame, it goes ahead and adds a new column in the resulting combine that it builds. Okay, does that make sense? Yeah, all right. Okay, so the data set gets wider after the combine. And by the way, combine is a real word, right? I had to look it up. I knew it was a real word. English is a wonky language, but it refers to a collaborative effort among a group of individuals for commercial purposes. That's what it means, but I'm using it in the sense of the bringing together of two things, which derives from the Latin. All right. Any questions? No? All right. So the other pathology that you might consider is what happens if they overlap in their columns. So the key values are not the same for the left frame and the right frame for all of the columns. So certainly with that, you could, when you build your combine, you're going to allow the merging of, in this case, column one and column two, because they have the same key values. But then the question is, what do you do with volume, which does not overlap with the key names from the left frame? Now, you could choose many things. You could say, okay, only combine things that overlap, or you could choose to say, I want to combine them even if they don't overlap. It's entirely up to you what behavior you specify. But the default will only combine those columns that have the same key names, both from the left frame and the right frame. And there are variations on that we'll talk about a little bit later. Okay. Any questions? Does that make sense? Okay. So when we think of what happens when we put together data sets, one of the things I've found helpful is you take your left frame, you take your right frame, and then you have this thing called a combine, which is a frame that you're building. And that combine has criteria that it employs about what it's going to admit from the left frame and what it's going to admit to the combine, that resulting list from the right frame, right? So if you think of it in terms of I iterate through columns and I iterate through rows and I employ some criteria starting with the default unless you tell me to do otherwise. And that's the decision it's going to make in what it's going to admit when it builds your resulting combine. Okay. All right. Any questions? No? All right. So when we have columns that partially overlap, meaning some of the columns are the same on the right and the left, you could make your data set wider, which is the default behavior, and also consolidate your redundancies, which is the default behavior. Again, in spite of the default, you can absolutely override it. What's important is understanding what this all means when you override the default options. Okay, because after all, if you are consolidating these two data sets, conceivably, you want to know what the volume is along with what the combined data is. And there's a typo there. It should be, yeah, that's right. That's right. Column 3 and the volume. All right. Does that make sense? No? All right. So it gets wider. And so there's several other pathologies, cases that are handled by the options. And probably if you were to enumerate all the options on the merge APIs, it'd probably label into maybe tens, like 50 or more different combinations you can specify, which is why we can't cover all of them in a semester. You could spend a month or two just on pandas alone. All right. So let's walk through an example, and I'm going to show you some code that is, it looks like correct Python. I consider it pseudocode. And then after this, we'll jump into a Jupyter notebook and try out one of the merges if time permits or as time permits. And so here we're constructing a data frame, and it's on purpose. I constructed this way to reinforce the underlying implementation as a list of dictionaries. So here we have name value pairs. The names are strings. These are the keys. And the value is a list of objects. And these name value pairs represent our columns in the data frame. And so here we have 3 columns, one called name, one called age, one called sex, and it's a mixed data set. The first column is string, the second column is numbers, so it's quantitative data, and the third column, you can think of it as categorical. You could call it strings, but they're really categories. And so one of the simple operations is the so-called concatenate. Merge is a little bit different. It provides a lot of different considerations for integration arbitrarily of the left frame and the right frame. But concatenate is just to paste one on the end of another. And there are a lot of pathologies to consider just for that simpler operation. So we're going to start with the concatenate with this example that will carry forward. And so here, I've just repeated it for convenience if I need to flip back and forth because it's not as visually pleasing to do it past the title slide. And so this is the basic API for concatenate. One of the options, it's really important, concatenate what, right? So these can be data frames. They can also be series. And so you're going to give it a list of references to the objects that you're going to concatenate. I haven't tried trying to concatenate a series to a data frame. It'd be interesting to try and see what happens. But these two objects, I assume, or I'm assuming, I haven't tried it, are of the same type. So you concatenate 2 data frames, or you can concatenate 2 series. And so you give it the data for the left data frame and for the right data frame, okay? Now, the axis controls what direction along which you're doing this concatenation. I said before, with concatenation, you're pasting the contents of each column from the right frame to the corresponding column for the left frame. But you could choose to change this behavior to make it row concatenation, not column concatenation. And so the axis allows you to control that. Now, this join type is interesting. It talks about how you handle your data elements. And we'll talk more specifically about what these join types mean when we get to the merge, because it makes a little bit more sense for the merge. But nonetheless, the default is a so-called outer join. And it's a database term, and I'm certainly not a database person. And you can think of an outer join as being an AND operation. It doesn't matter what values each of the columns contain. You're just going to put them all together to create the resulting combine. And so that matters in cases where you have different column names, because if we go back to this figure, if you have a consolidated data set, and let's say the second column, for example, that last column, volume, has more entries than the first one, the left frame doesn't have any values to contribute for that entry at offset number 6, right? So you have to fill in something, and that something is the nothing entry or not a number, Okay. And so this idea of the join type, you can control for what to do when you don't have available data for the two things that you're trying to admit to your combine. And I'll show you more detailed example about the different join types in towards the end of today's module. Okay. And so we talked about the index because when you do a concatenation, if your combine grows taller, you need to do something about that index. You can keep the indices from the left frame and the right frame, or you can ask Pandas to rebuild your indices. And when you rebuild your indices, you're recounting all of the available offsets for the resulting lists for the column information for the combine. And so in that case, for example, no, I'm not going to do that. It's just too wonky to go back. Does that make sense about rebuilding the index? Yeah. Okay. And so keys. Keys are the criteria used to merge, and keys refers to the keys, the names, which are the column names for the left frame and the right frame. And when you do the join, you can tell it or do the concatenation what criteria to use, what values to use when you're trying to put them together, right? Make it taller, the combine taller. And so so-called multiple keys uses different criteria, i.e. the values in different columns, and you can specify the order in which it uses these values. And what I mean by that, suppose you were doing a merge, concatenation, and you use age as the basis of doing that concatenation. If you're going to do that, okay, we see that age has values of 22, 35, and 58. When you're building the combine, one of the things you can do is say, use this age column as the basis for your concatenation. But when you pull in all the other records, you're going to sort it based on the values in this particular column. And that can be useful for a whole host of things. So for example, if we looked at the Titanic data set, we have the ages of the passengers from the manifest. And it might be important to you when you build a combine by concatenation, maybe you have the age of the passenger, the name of the passenger, and then in another list, you have the name of the age of the passenger, name of the passenger, and say their health status, right? And so when you build a combine, it might be important to you for the resulting combine, that data set you're building, by admitting records from the left data set and right data set, it might be important to you to make sure that the values, the rows in the resulting combine are sorted in age order. Okay. All right. Any questions? Does that make sense? Okay. All right. Moreover, levels, you can use certain keys as the basis of sorting, but you can use more than one key. You can have a first level sort, a second level sort, and you can use as many different keys as you want, and you can specify an ordering in which you base your sorting criteria when you admit records to the combine. Does that make sense? Any questions? No? Okay. Then levels, names. Oh, I can't remember what this one does. I honestly can't remember. Oh, yeah. Okay, all right. Names refers to, excuse me, when you are building a combine, the default behavior is that it assumes that if the column names are the same, then those contain the same information. And so if for whatever reason, let's say you had age and as an age column in one in the left data frame, and in the right hand frame, you had some other string corresponding to age, right? Maybe it was age in a different language, right? And so when you are integrating by concatenation, the left and the right frame, sometimes the names of the columns aren't the same. So you have to tell Pandas that even though these names are different, I want you to assume that these are the names you're going to use when as the basis of your concatenation. Does that make sense? And so there's lots and lots of variations for all of these, and we can't possibly cover all the different variations. Okay, so verify integrity talks about duplicate checking. It's fairly straightforward. You can sort your concatenated axes, and then copy. This is an important one, especially when your data frames are large. And so when you say copy true, it when it constructs the combine, it creates a new copy of all the data underlying the combine. When you say copy equals false, it, as much as possible, it uses a reference to the original left and right. And for many applications, it's more memory efficient, especially when your data set grows large. It's more memory efficient to use copies of things, to use references to things rather than copies. Okay. Any questions about this? All right. And so here's an example. And in this, let me release my pen. There we go. In this, we have, I'm going to use the pen again. We have 3 data frames. We have data frame 1, 2, and 3. And data frame 1 has, I'll use the red here. Data frame 1 has 3 keys, column 1, column 2, and lastly, column 3. Okay. Column 1 has numerical data, so there's the list associated with column 1 for data frame 1. And then we have alphabetic characters, and then we also have alphanumeric strings, okay, for column 3. Data frame 2, its keys, column 1, column 2, and column 3, and we notice the spelling for the keys or the column names are identical to data frame 1. And so if we produce a concatenation between data frame 1 and 2, the assumption is that all of the data for column 1 for data frame 1, if that's the left frame, is going to be appended with the list items for data frame 2, assuming that's the right-hand frame. And that's the default behavior. Okay. Same thing for column 3. All right. But data frame 3 is a little bit different. It has 3 keys or 3 columns, just like the others. The first key is string column 1. We have column 2, and we have column 4. And so even though the data types are the same, we have the first column has numbers, 7, 8, 9. The second column has characters, G, H, I. The next column, the third column, positionally in data frame 3, has alphanumeric, okay? Well, we noticed just from examination that they're all the same data types. But the difference is for data frame 3, this last column here, call 4, has a different key name from that last column for data frame 1 and data frame 2. We have column 3 here, and we have column 3 for data frame 3. Okay, so with that, the first thing we're going to do is we're going to print out the data frames. Okay, that's not very interesting, but it's still important to visualize what's going on. And so here we have data frame 1. I'm just going to label it. We have data frame 2. And lastly, we have data frame 3. Okay. And so on purpose that I specify them as dictionaries, it's not the only way you can instantiate a data frame. It just reinforces what we've been talking about for the underlying implementation. Okay. So now we're going to do a simple concatenation. And for this concatenation, let me just mark again. We have data frame 1, data frame 2, and data frame 3. And the observation we had is that the column names for data frame 1 are the same, so same keys as is for data frame 2. So when we do this concatenation, we give it a list of the objects that we're going to concatenate. So you can make the assumption that in the case of 2 frames, the left data frame is the first position in the list, and the right data frame is the second position in the list. So if we go ahead and do that concatenation, well, the default is something called an outer join. An outer join says that if we're going to merge, this default behavior says assume that everything that's in column 1 is the same thing as what's in column 1 here, the key names that are identical to one another. And so the other thing is that outer join says we're going to put them together using effectively an OR criteria. If it's in the left-hand list or the right-hand list, it doesn't matter. You're going to admit that to the resulting combine. And so here, when we print out the resulting concatenation, okay, well, we have column 1, and this is the combine. We have column 2, and we have column 3, because this is the simple, straightforward case where both the left and the right data frames had identical key values or key names for each one of its columns. Okay, does that make sense? Any questions? All right. And so here we have, okay, column 1's information that's contributed by the left data frame here. Column 2, the first 3 are contributed by the left data frame. The first 3 in the resulting combine, that's contributed by the left-hand data frame. And so now the bottom 3 elements in each list, each one of these is contributed by the right-hand data frame. Let me select a different color. So here, 4, 5, 6, that's contributed by the right-hand data frame, and we see that here, column 1. DEF, that's contributed by the right-hand data frame. And then lastly, D4, E5, F6, that's contributed by the right-hand data frame. So everything here was contributed by the left to the combine. Everything here was contributed by the right. Okay. Any questions? No? So I'll also direct your attention to the left-hand column of the resulting combine. You notice the default index for the first 3 is 0, 1, 2, and the default index for the next 3 is also 0, 1, 2. And that's because the default behavior was to preserve the original indices. As we see here in the left-hand frame, which was data frame 1, we have 0, 1, 2, the default index. In the right, it was 0, 1, 2, also the default index. Now, of course, if these were dates, for example, for stock, if this said, 3, 3, March, no, 3, I always do the other one in my mind. So month is first in the US, 3, 1, 23 or 2023, 3, 2, 2023, and so forth, right? And if this was 3, 3, blah, 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 and this is 3, 4, 2023, of course, it would make sense to preserve this index when you build the combine, because you don't want it to renumber these, because these indices are meaningful. It's the specific date associated with each one of these measurements. Does that make sense? Any questions? No? No, I'm kind of laboring so long over this because it's really important to get an intuitive feel for what the underlying algorithm is doing, because it gets more complex when you talk about arbitrary merge. Okay, now in this example, it's the same type of concatenation. The left frame is data frame 1, which we have here. The right frame is data frame 2, which we have here. So that hasn't changed. And we're using the default behavior. So we see that column 1 is here. The same key name, column 1, is here. Same for the other columns. So it's going to do that concatenation row by row, column 1's information concatenated with column 1's information, and so forth. But the default here, we're overriding this ignore index. So saying ignore index is true. Go ahead and ignore the default index, or the index, I should say, for the left-hand frame here, which is the default index, and for the right-hand frame, which is also the default index. Now, if we do that ignore, okay, well, it infers what it should do to build this index anew. So here, you'll notice the last 3 index entries for this default index is 3, 4, 5. It continues on in its count. Okay, and it should do the same thing for dates if you wanted to continue the dates for whatever reason. Okay, any questions? Does that make sense? Yeah, all right. So here, let me make sure I know what I'm doing. Yeah, okay, all right. Now, this is one of those pathologies that goes against what the default behavior is. And so again, we have our three data frames. We have data frame 1 here up top, data frame 2 in the middle, and data frame 3 down bottom. We already said data frame 1 and data frame 2 have the same key values for its column labels, right? These keys for the dictionaries representing the column information. But here, data frame 3 is a little bit different. For the first and second column, yeah, the key values match both data frame 1 and 2. But this last column, even though it has the same information, type of information, these strings that are alphanumeric, the key value is very different. It's column 4. And so in that case, if we do the default merge between data frame 1 and data frame 3, let's examine what happens and consider the algorithmic implementation. So here again, the objects that we're concatenating, this is the left frame and this is the right frame. And we know from the left and the right, well, the first two, column 1 and column 2, column 1, column 2 for frame 1, the left and the right, it's the same key. So that's a straightforward merge that's going to happen. But for that last one, in data frame 1, it's column 3. But in data frame 3, it's column 4. The two are different. So when you build your combine, well, you have your left, you have your right, you have some admission criteria, taking from the left and from the right, and then you're building your combine. Okay. Well, for this combine, what do we know? Well, we know columns 1 and 2 have the same information, right? The same key name. So we're going to say column 1, column 2. We have all the same information, and that information spans from the first 3 entries, 1, 2, for column from data frame 1, and then the next 3 entries, 3, 4, 5, contributed by the right-hand frame. And so for columns 1 and 2, these come from the left, and for columns 1 and 2, these come from the right. Okay. So then the question is, what do you do with those columns that are not the same or the keys are different? Okay. Well, we know we're concatenating the right or tacking it onto the end of the left. So we have a column 3, and that's going to get information from the left. Okay. But then what do you do for the right-hand information for column 3? There is no column 3 contributed by the right-hand frame, which is data frame 3. But you still have to fill in values. So there's a nothing value. So you get not a number, NaN, for those last 3 values, which are placeholders for the contribution to column 3 from the right-hand frame. Does that make sense? Any questions? No? All right. So that would, and then likewise, we have column 4, because the default is an outer join, take everything from both the left and from the right, regardless if it exists in both. So column 4 says, okay, well, on the left-hand side, there is no column 4. And there are 3 positions in the list. You still have to fill in a value. So you fill in the nothing value, not a number, for that contribution to the combine for column 4, contributed by the left-hand frame, which is nothing. And then you have for the right-hand frame, you have G7, H2, and I3, which are these values contributed by column 4 by the right-hand frame. Does that make sense? So it's really important to think at a gross level about what the algorithmic implementation is doing. So should things go wrong, you say, aha, that's what Python is referring to. Because I know some of these Python messages can be like, what the hell is it talking about? Okay. All right. Any questions? Does that make sense? Yeah. All right. Good. So now, so to remind myself, what did I say here? The default behavior is a so-called outer join. And the outer join says it doesn't matter if the left or the right has information. I'm going to take what's on the left or what's on the right. And that's what a quote unquote outer join is. Okay, so the other type of join is called an inner join. An inner join implements an AND function. So if we have our left data frame and we have our right data frame, we have our admission criteria, and we build, as a result of that admission criteria, we build our combine, right? Okay. So the question then, this difference for this concatenation, again, we're using data frame 1 as the left-hand frame. We're using data frame 3 as the right-hand frame. We're going to ignore the index, okay? So that means we're going to rebuild the index from 0 through 5, so 6 many things. And this time, we're overriding the default behavior. Now we're saying do a so-called inner join. And what the inner join implements is this idea of an AND. The outer join is this idea of an OR function. With an AND, the semantics of AND, or behavior of AND, says in order to be admitted to the combine, they both must be present. They both must be the same. And so what that means is, if we have data frame 1 as our left frame and data frame 3 as our right frame, see, if we take the 0th position column through the 2nd position column, contributed by left frame, we have column 1, okay, and we have column 1. Oh, they're both the same, and, okay. So we're going to admit the data for column 1 for the left-hand frame and the data for column 1 for the right-hand frame, or the 0th column that you encounter. Does that make sense? Any questions? No? All right. So then we go to the next column, okay? It has a name of column 2, and for the left-hand frame, it also has a name of column 2, okay? So when we make the admission of data records to the combine, we're going to take the data contributed by the left-hand frame, and we're going to append to that the data from the right-hand frame. And then we go to the next column in our left and right data frames. Here, we say, okay, the key value is column 3. Here, the key value is column 4. Uh-oh, they're not the same. It's not true, okay? So that means you're not going to contribute that data for that next column, that last column, and you're not going to contribute that last column. And so when we look at the resulting combine, we see here that we have all the data from column 1 contributed, the first 3 items from the left-hand frame. These last 3, 7, 8, 9, contributed from the right-hand frame. And then we have here ABC, that's the next column, contributed by the left-hand frame. GHI is contributed by the right-hand frame. And you'll notice there's nothing else here. If we contrast that with the previous slide, all of the columns are contributed, and you fill in these nothing entries where you have these undefined gaps. Whereas with the inner join, it implements an AND criteria for building the combine. And we notice that we don't get columns represented where they're not in both the left as well as the right. Okay? And any questions about this? Does that make sense? Okay. All right. So again, it's really important to have a high-level understanding of what the algorithms are doing underneath the covers. So should things go wrong, it's easier to figure out how to correct it. Or you get the behavior that you're not anticipating. All right. So now we're going to make this a little bit more complex. We have 3 data frames here in our list of objects that we're going to do a concatenation on. And now I kind of wasn't being entirely truthful when I said a left and a right-hand frame, right? So let's give these names just for the sake of consideration. Let's call the first frame the left. Let's call that last frame the right. Let's call this one here, let's call it the middle. Okay, so here, frame 1, that's our left. Frame 3, that's our notional right. And then this frame number 2 is our middle. Okay, now you notice here, when we do the concatenation, there's an ordering in the list. In first place, or if you want to be Python-y, in 0th place, you have left. In first place, next place position, you have middle, and then in that last place, you have the right. So when you do the concatenation, it's going to start with left, concatenate the middle, and then concatenate the right. And so here we have left, we have middle, we have right. Okay. And then we're going to build our combine, but the criteria for building the combine is going to be an or in this case, because we're using the default behavior, the join type. If we use the inner type, the and criteria, you'd only see columns 1 and columns 2 because those are the only keys common to the left frame, the middle frame, and the right frame. But remember here, we don't specify that option. And when you don't specify the option, the default is a so-called outer join, which is an or criteria that you employ when you're building the combine or admitting records to the combine. Any questions about this? Does that make sense? Yeah? No questions? No? All right. So here in the resulting combine, we see first the contents for column 1 contributed by the left frame, the contents for column 1 contributed by the middle frame, the contents for the combine contributed by that last frame, the right. Likewise, same thing for column 2, contents of frame left, contents of the middle frame, contents of the right frame. Now here's where it gets interesting. Column 3 exists in left and middle. So we see the contents contributed by the left, contents contributed by the middle, but the right, it doesn't have a column 3, but it still has to come up with entries. So it's the nothing entry, not a number, placeholder contributed by the right-hand frame. Likewise, there is no column 4 for the left and the middle. So contributed by the left on its behalf, you have not a number. By the middle, not a number. And by the right, you have its contents because it has a column 4 key. Right. Any questions about this? Does that make sense? All right. So we have the data frame positionally in the list of objects. And then we have the type of combination, the criteria employed when building the combine or admitting records to the combine. And then we have this ignore index. You'll see that it continues this numbering for all of the 9 going from 0 to 8 as the default index that it built or rebuilt. Any questions? No? All right. Hopefully we get through all of this. And so there's another API called append. And append is tied to the data frame object and the series object. And it's a shortcut method on the concatenation. You'll notice here in the API, concatenation is called from the pandas module, but associated with the data frame is the append. And if you use this, and I'll comment a little bit about it, not spend too much time, this is the left-hand frame, and this is the right-hand frame. So in this case, you're taking the first frame and you're concatenating to it the second frame. And all of the same options apply, like ignore index and the join type, which changes the criteria employed when you're trying to admit records to the resulting combine. Any questions? No? All right. But wait, there's more, right? One of the things you can choose or specify is whether once you build a combine, if you're going to sort the resulting records when they're admitted to the combine. There are cases where it's important to sort. Maybe it's string names in the lists. Maybe it's numbers. And for whatever reason, you don't want to preserve the order in the individual frames, left and right, contributing to the combine. You want to sort them when they arrive in the combine. So those are options that you can specify. But wait, there's even more for just $19.99. No, that's these APIs on the data frame are so-called deprecated. And deprecation, I'd like to say, I worked at Sun. I remember when it happened. Deprecation is a mechanism to give you a type of warning in your runtime, whether it's through debugging or through an interpreter like Python, to tell you, hey, heads up, this is going to go away at some future version of your API. And so when you're developing your code, if you see a deprecated API, you'll get the warning. It'll still run, but you might want to enterprise to change your call based on what the deprecation warning says. Now, that's really important if you're in industry. Certainly, when you implement the library, you're going to change it over time to correct things, make things a little cleaner, etc. But if you have a system and you don't pay attention to the deprecation, eventually your system's going to break, right? Because the API ultimately goes away. And so here, for the append shortcut tied to the data frame and tied to the series, it tells you it's been deprecated since version 1.4 of Pandas, right? This is 1.4 Pandas, not 1.4 Python. Python's up to 3x. And so then it'll also say this was changed in version 1.0.0. That was when it started, but the deprecation message is telling you that when it's going to go away. So if you're using older versions of these different libraries, like you're using an older version of Pandas, and the one I'm using is 1.5 point something, you really want to pay attention to these deprecation messages. Okay? All right. Any questions? So that's just to say append method or API call tied to the data frame or the series is going away. They advocate you use concat, which is from the Pandas module. It's not wrong to use it if it still works, but it's one of those sort of software engineering things that you might want to change it because you can have failures in your code going forward after some point. All right, any questions? No? All right. So let's take a look at merging. And this is where, good, we're right on time. I'm going to spend the next 15 minutes, and hopefully we get a chance to just see this in a Jupyter notebook, which is what I have planned. So here's a data frame. I won't go over the structure of the data frame. And again, I repeated this for convenience so we can flip back and forth. Now, merging is sort of, the grandma of it all, right? You can implement what looks like concat using the merge API, or because concat is a lot simpler, you're just tacking on one data frame to the right to the end of the left. But merge talks about all sorts of interleavings that you can have of the left and the right data frame. Now, as you can see, there are a lot more options here and things you can specify. And we're going to walk through a bunch of them, commenting and then having some examples in the following slides. Hopefully I can do this in 15 minutes. I don't want to rush through this. So certainly, if I don't finish, we'll just pick up the balance of this on Monday as we continue forward with our material, since this is such an important feature in Pandas. So we start out with the merge, and unlike the concat, you'll notice the merge only takes two data frames, the left and the right. We saw with the concat that it takes a list, and I was sort of, not being entirely truthful when I said left and right, but I wanted to frame it in merging and not in terms of concatenation. Concatenation will take a list, but merge only takes the left and the right because this is so complex and there's so many variations. So here you can specify either a data frame or a series. And again, I haven't tried the merge between a data frame and a series. A series, if you think about it, it's a disconnected column from a data frame. So it makes sense that it would implement it, but you'd have to ask the runtime, try it and see what happens, right? But that being the case, we specify our left and right data frame. And now it's no longer type, it's how. Why is this how and not type? Maybe somebody missed the engineering meeting. I don't know. But that being the case, the way you do the merging is very, very important to the behavior of the merge. And this is often called the join type. Join is a database term, and it's used to describe the putting together, which isn't necessarily concatenation. It's a type of join, it's a very simple type of join, but the interleaving potentially of two different tables worth of data. And so the how option, it defaults to inner. And like we saw before with concat, inner employs an and criteria. The things that you're trying to put together, it must be both in the left and in the right data frame, each column's worth of data. And that's the default behavior. But there are other behaviors that we'll talk about. I think it's in the next slide or two. Okay. Now, this next option on. Now, when you do a merge, you're going to merge based on some criteria. And as we talked about, the column names are used to determine what lists worth of information you're going to put together. Now, these lists, the default behavior is that we assume that lists that have the same key values are going to be the same pieces of information. Let me make sure I did not. Yeah. So when you specify on, you're telling it what key values to use for the basis of this merge. And the reason for that is that you might have the same information, like first name, but the column names might be different. And so the assumption here is that if you say on is none, it's going to assume that the same key, where capitalization matters, is the same information, and you're going to append or integrate like keys with like keys. But if you specify values, a list of key names in this on option, it's going to override that default and use those particular column names as the keys on which it bases criteria for building the combine. Does that make sense? Any questions? No? So now, this is why they implemented it this way. I would love to, know the history. Not only can you specify the keys to use, there's this other way called left on and right on. So again, the model is you have a left-hand data frame and a right-hand data frame, and you're putting them together. One of the options you can specify is if you have a key name in the left-hand list, but it's different than the right, or if you have a key name in the right-hand frame and it's different on the left, you can specify what that name is and what those equivalencies are. Why they did it this way instead of using the on list, it's a great question. But I think one of the answers resides in this how option, because there's something called a left-hand join and there's something called a right-hand join. And so the left key value matters and the right key value matters when you do this left-hand and right-hand join, which we'll talk about in just a slide or two from now. Okay, so then we also have left index and right index. Now you can do a join or merge based on the key values. It employs the columns information as the basis of your putting together of these lists or these records of information. You can also use the index. And so we have the default index, okay, and you can choose to say, okay, put together the left and the right data frames based on the index values. And we've seen when you use the default index, that's just a natural number from 0 to whatever value k should be. If you have stock information, maybe you've replaced the default index with the date stamp, and you can also merge based on this date stamp, replacing the default index. And so you can employ the key values or the columns as the basis of your putting together of the left and the right frames, or you can use the indices, and these are separate options. Why you don't just specify the string name for the index? That's a great question. Again, my kind of half serious joke is that maybe the person that implemented this missed the engineering meeting when they were talking about it. But that being the case, you can also sort, and I won't talk about that. This next one, suffixes, is a little bit weird. When you put together two data sets, we saw from the concatenation that if you have the same key names, like column 1 and column 2, it'll put together those pieces of information from the respective lists from the dictionaries representing the columns for the left and the right data frame. But when you merge, you also, like we saw with concat, you can bring in other columns, admit other columns to the resulting combine that are not in both of the left and the right. And we saw that the one data frame left had a column 3 and the right data frame had a column 4. We still added the column 4 and column 3 to the resulting combine, even though they weren't common to both. right, as so-called outer join. And so the question then is, if the left-hand frame has a column that's brought in and the right-hand frame has a column that's brought in, if these columns have the same name, like name, right? How do you know which one came from the left-hand frame and which one came to the combine from the right-hand frame? And so they use this thing, suffixes. The default is underscore X for the left-hand frame and underscore Y for the right-hand frame. You can override this default behavior, and I have an example for this by specifying a tuple. And it's a tuple because the order matters. The thing on the left part of the tuple, that is the left-hand frame, and on the right, that's the suffix for the right-hand frame. So if you had a left frame and a right frame, and say a column called column 1, and then you had other columns that weren't used as the basis of the merge, and those columns had the same name, it's going to go ahead in the resulting combine and have two columns called name. So how do you know which one is which? It's going to say name underscore X, use that suffix for that column with the same key value contributed by the left-hand frame, and it's going to say name underscore Y for that column contributed by the right-hand frame. That's only where you have same names that aren't used for the basis of the merge. Does that make sense? Okay. And then I won't talk about the other three because I want to get to some of the examples. So the join type, and I'm running out of time, I'll make sure I maintain my methodical pace, and we'll pick up with the balance on Monday. An inner join, we said, corresponds to the AND criteria for admitting records to the combine from the left and the right frame. And as we saw with concatenate, when it's an inner join type, that data must exist both in the left frame and the right frame. But with merging, it's not just the column name, it's the data itself, right? And we'll see some examples about that. An outer join implements an OR criteria. And it says it doesn't matter what you have in the left or the right, is when it builds the combine, it's going to put all of them in there, regardless of if it's overlapping or it's unique from the left and the right-hand frame. Then we have this left join and right join. That's where that left on, right on comes into play. What a left join says is that I'm going to build my combine starting with everything that is contributed or available in the left-hand frame. And then when I continue to build my combine, I'm going to go through the right-hand frame and I'm going to start to populate what I have so far from the left with elements of the right-hand frame only if it's shared with the left-hand frame. And so here in the Venn diagram, we see all of the left-hand frame, and that portion of the records from the right-hand frame that are admitted to the combine are those that satisfy the AND criteria for the stuff that's already there in the left-hand frame. Does that make sense? Okay. And it's sort of like set difference, right? You have everything from the left, but you're going to take only those things from the right that are common with the left. Okay. The right-hand join is the opposite. You specify, why wouldn't you just reverse the parameters and call left-hand join? You could certainly do that. Again, I would love to hear the reason why they did that. But you specify your left-hand frame and your right-hand frame. And then when it builds the combine, the first thing it does is puts everything from the right-hand frame into the combine. Then it iterates through the left-hand frame and populates in those things from the left-hand frame that are in the current version of the combine, which started out as everything in the right-hand frame. And so this right-on value for the key is really important in support of the right-hand join. Okay. Any questions about this? Does that make sense? And this is where it gets kind of weird with the left and the right and the inner and the outer as far as the merge is concerned. So we'll end with this slide since we have about 3.5 more minutes left, because I really am trying to resist trying to squeeze too much in, because this can get very confusing very fast if we don't take our time. And so here we have, again, a data frame, 3 of them. And first one we'll call books, second authors, third call sales. And this first data frame, we're going to have some identifiers for author, kind of like your student ID number, an identifier for a book, kind of like the ISBN number for a book, and then the name of the book, right? So that might be a typical data set you'd find at a bookstore. And then we have this authors array. We're going to have the same author ID or array of author IDs, and we're going to have the name of the author, right? So maybe you sell a book, you're trying to figure out who gets the royalty for that book sale, all right? And then we have sales numbers. This last one, we have 3 columns, author ID, okay? Then we have the book ID, and then we have set of counts in our third dictionary entry, sales representing the number of sales for each one of those books. And so certainly, if you wanted to, in an application, calculate how much royalty or how much book sales an author has, whether you're going to win the Pulitzer Prize or not, and I don't really know, that's my ignorance, if Pulitzer Prize is number of book sales or if it's quality of the book. Maybe you can tell me. But let's say you want to compute royalties, right? You have to know the book, you have to know the author, and you have to know the sales. So conceivably, you might want to, with these 3 frames, put together this data into a consolidated data frame, your Combine, so that you can then iterate through, do some analysis to calculate these things. Okay. Any questions about that? Make sense? So I'm going to end here. And next time on Monday, we'll pick back up with a number of variations for the merge, and we'll frame that in what the underlying data structure is doing in the runtime and show you some examples both here on the slide as well as live in a Jupyter Notebook. So we'll end there. Please don't hesitate to reach out if you have questions about the project number 3, and have a great weekend. I'll see you all on Monday.